Hey everyone, so I hope you looked at the PowerPoint of the review because there was some important information on the first few slides. So if you haven't, go back and look at that. And then if you downloaded the Word document review, we're going to start at number 3 because number 1 and number 2 are typed out in that review PowerPoint for you. So I'm just going to skip over those because it's clearly explained there. And so we're going to start with number 3, which 3 through 7 all have this question. What intermolecular forces are found in the following? So whenever you're trying to decide what intermolecular forces there would be, it's important you have to start with drawing the Lewis structure. And so for HCl, the Lewis structure would be this. And then you need to go look at the bond polarity and is that a polar bond or not. And hydrogen and chlorine do form a polar bond. You know that based on the electronegativity values. And chlorine is the more negative, so the arrow points towards chlorine. And then looking at that, that is asymmetrical. There's not another bond canceling it out, so it is a polar molecule. And therefore, it has London dispersion forces because everything has that, and it has dipole-dipole forces. It does not have hydrogen bonding because hydrogen bonding only occurs when you have hydrogen bonded to HN or, what did I say? ON or F. Okay. Number 4, NH3. That Lewis structure is boom, 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 and there's a lone pair on the nitrogen. If you go look at the electronegativity values, these are polar bonds. Nitrogen is more electronegative, partial positives, and then this is asymmetrical. They don't cancel out because they're all being pushed down versus a trigonal planar where they do cancel out, and there's that lone pair on the center atom, so it is a polar molecule. And it's got London dispersion, dipole-dipole, and the rule for hydrogen bonding, you have H connected to O, N, or F. And right here we have N and H, so it has hydrogen bonding, all 3. Okay. Number 5, CH4. That Lewis structure is boop, 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 boop. That is a non-polar bond, and it is a non-polar molecule. And it only has then London dispersion forces. Water. And I go to the electronegativity values. That is a polar bond. And they don't cancel out. Plus, there are lone pairs on the center, so it's a polar molecule. Dipole-dipole, London dispersion or van der Waals, and then hydrogen bonding happens when you have an H connected to an O, N, or F. Well, we have an H and an O, so hydrogen bonding, all 3. And then the last one, HF. Now, hydrofluoric acid, HF, the electronegativity value is above 1.7. I think it's like 1.9 or 2.0, but it is a polar bond. It is an exception. It is a polar covalent bond. And the Lewis structure is just like HCl, a single bond connecting hydrogen and fluorine, 3 lone pairs around the fluorine, and it's a polar molecule. And it also has all 3. Okay, next, properties of solutions, suspensions, and colloids. Number 8, the substance that does the dissolving. So looking at these two, does the dissolving, gets dissolved. It might be easier to answer which one gets dissolved first. And the one that gets dissolved is the solute, so B. The other one is the one that does the dissolving, which would be E, the solvent. Solute gets dissolved, that's like your sugar. Solvent Water. Water solvent. 10. Particles settle out in this type of mixture. Settle out, I like to think about Italian dressing. Settle out, like you have to shake it to mix it back up. And Italian dressing is the big example of suspensions. 11. A solution is what type of mixture? Solutions are only homogeneous mixtures. Homogeneous mixtures are solutions. 12. Using your high beams on your headlights is dangerous on a foggy night because of this. Let me also scratch that out before I get started. That is because of the Tyndall effect. Light, you know your high beams have light. Light shines through the foggy air, and the light can travel through. It reflects off the larger particles. I don't really like that question. Don't worry about that. 13. Particles don't dissolve, yet are small enough so that they don't settle out. That is the middle one, colloid. Colloid, they're not small enough to get dissolved like a solution, but they don't settle like suspensions. And then 14, increasing the pressure increases the solubility of this. That is F, a gaseous solute. When I increase the pressure, more gas can dissolve. Now, pressure does not affect solid solutes, only gaseous. Okay. True or false? And this is continuing with properties of solutions, suspensions, and colloids. 15. Polar compounds will dissolve ionic compounds. That rule, like dissolves like. Polar compounds have charges. Ionic compounds have charges. That is true. Polar compounds can dissolve most ionic and polar things. 16. The particles dispersed in a colloid are much larger than those in a suspension, and they settle out easy. That is false. Suspension is larger than colloid. So, false. 17. A suspension is a homogeneous mixture that does not settle out if left undisturbed. That is false. First, suspensions are heterogeneous, and they do settle out. 18. An unsaturated solution has dissolved exactly as much solute as theoretically possible. That is false. That is describing a saturated solution. 19. Water is an effective solvent because of its polar nature. True. It can dissolve most things that are ionic in most polar things. Water can only not dissolve non-polar things. So it's pretty effective. It can dissolve 2/3 of things theoretically. And then 20. Increasing pressure will decrease the solubility of a gas. That is false. If I increase the pressure, a gaseous solubility, that's a lot of sols, will increase. But that's only true for gas. Pressure doesn't affect solid solutes, like I said on the last slide. Okay, now we're going to look at solubility curves. And again, this is the curve. It's in the notes from last Thursday. It was on your practice page. This is the curve that we're using on the test. So print this curve out. If you message and say the picture of the solubility curve wouldn't upload, I'm not giving you another try. You just missed those questions. Have the PowerPoint downloaded. Have the solubility curve up, please. Okay, so 21. How much potassium chlorate will dissolve in 200 grams of water at 100 degrees Celsius? So this graph is about 100 grams of water. I want to know about 200 grams of water. And we're asking about potassium chlorate, which is this right here. And let's just look really fast. So at 100 degrees, about 60 grams, let me change to pen, 60 grams can dissolve in 100 grams of water. If I double the water, that means I can double the amount of solute that can dissolve, so 120 grams. Because 60 times 2 is 120. 22. 50 grams of sodium nitrate is dissolved in 100 grams of water at 25 degrees Celsius. The solution is, so we're looking for sodium nitrate. Sodium nitrate is this one up here, and at 25 degrees, it can dissolve about, I don't know, 94 grams. Well, we're dissolving 50 grams. 50 grams is way down here. It can dissolve more, so the solution is unsaturated. 23. How many grams of sodium chloride would dissolve in 75 grams of water at 70 degrees Celsius? Sodium chloride is this blue line right here. And at 70 degrees, it can dissolve about 40 grams. It looks like it's right on there. But I want to know if we have 75 grams of water. So let's set up a proportion because this isn't such a simple one, like multiplied by 2. And so you can cross multiply, solve for x, or I just like to think about it going from 100 to 75 is like multiplying by 0.34. Hold on. I'm not 0.34, I'm thinking of a fraction. 0.75. So 40 times 0.75 would be 30 grams. You could set this up as a proportion and have x up here and solve for x. Either is fine to do. It will give you the answer no matter what. 24. Okay, so getting to our math problems. These are molarity problems. Reminder, the formula is molarity equals moles over liters. So I want to know what is the molarity of a solution that contains 3.2 moles of potassium nitrate and 450 milliliters of solution. So molarity equals moles over liters. We have our moles, 3.2, but this 450 milliliters, it has to get changed to liters. You do that by that should be a dividing sign, not a plus sign. Divide it by 1,000, 0.45 liters. And then we can plug that in. And that molarity would be 7.1. 3.2 divided by 0.45. Number 25. What is the mass of iron 3 chloride that is needed to prepare 2 liters of a 0.255 M solution? So I want to find mass. Mass is grams. The only way, thinking about our molarity formula, M equals moles over liter, the only variable that gets you to grams is moles. And so we will have to solve for moles first, and then we can solve for grams. Okay, so I have my molarity, 0.255 M equals moles over 2 liters. I'm trying to solve for moles, multiply each side by 2. And then I have moles by itself now. So the moles is 0.51. Now, I'm trying to find grams, and it's iron 3 chloride. That means iron has a charge of 3, chloride, Cl1 negative, So that formula is FeCl3. That matters because we are going to have to find molar mass. And if you have the wrong formula, the molar mass will be wrong. So let me erase really fast. And 0.51 moles of FeCl3. I'm trying to find the mass. 1 mole of it has 162.204 grams, and so that's 82.7 grams. (26) What's the molarity of sodium carbonate in a solution prepared by dissolving 85.6 grams in enough water to make 250 milliliters? So I want to find molarity. Molarity equals moles divided by liters. I have milliliters, which equals 0.5 of a liter, but I don't have moles. I have grams. So we're going to have to change grams to moles first, and then we can plug in and solve for molarity. Okay, so 85.6 grams. Now this is sodium carbonate. Sodium is Na with a charge of 1 plus, carbonate, CO3, 2 negative. So this formula is Na2CO3. Again, have the wrong formula, wrong molar mass, wrong answer. So you don't want that. And we are changing this mass to moles. So up top, 1 mole. At the bottom is the molar mass of sodium carbonate, which is 105.988 grams. And that tells us we have 0.8076 moles. And we're going to need that number. Now, that's moles, not molarity. I'm not done with the problem. Just run out of space. So let me erase. Okay. And the molarity equation, molarity equals moles over liters. So 0.8076 divided by 0.5. Erase that because that's not my final answer. And when I divide those two, the final answer is 1.62 molarity. Number 12. Not number 12. I don't know why I said number 12. Number 27. How many grams of calcium nitrate are needed to make 3.30 liters of a 0.1 molar solution? So we're looking for grams. Again, grams will come from moles. So we will have to solve for moles first. We have liters, we have molarity. Thinking about the formula, molarity equals moles divided by liters. 0.10 molarity equals moles over 3.30 liters. We're solving for moles. Multiply each side by 3.30. And that gives us a moles equals 0.33. Now let me erase really fast. And I'm going to erase all of this. I want to find grams. Calcium nitrate. Calcium has a charge of 2 plus, nitrate NO3 1 negative, so that formula is CaNO3 2. Now remember, when you're solving for molar mass, the calcium will get multiplied by 1. Nitrogen's molar mass will get multiplied by 2. Oxygen's molar mass will get multiplied by 6. That 2 means that there are total 6 oxygens. And let me erase this. So 0.33 moles of calcium nitrate times 1 mole at the bottom, and the molar mass of calcium nitrate is 164.086 grams. Multiply those, it's about 54 grams. Number 28. Now, it's telling you this is a dilution problem. Looking at this, I know it's a dilution problem because it says that 30 milliliters of a 12 molar HCl stock solution are diluted to a volume of 500 milliliters. What's the molarity? So there are two volumes. That gives me my first hint. It's a dilution problem. And then I'm asking about another molarity. If you're using this formula, there's only going to be one molarity in one volume. That's not the case with this problem, so it's not that formula. It is M1 V1 equals M2 V2. So my M1, 30 milliliters, times my molarity 1, 12M, is going to equal, I'm looking for M2 times 500 milliliters. 30 times 12 is, that's a great question, 360, I should probably know that, but oh well. M2 times 500 milliliters. To solve for M2, divide each side by 500. 360 divided by 500, our M2 equals 0.72 molarity. Number 29. If 50 milliliters of a stock sulfuric acid solution whose molarity is 15 molar is diluted until the molarity of the new solution is 2.5 molar, what is the volume? M1 V1 equals M2 V2. We've got two molarities. We're looking for a second volume. It's this formula. Okay, 50 milliliters times 15 molarity equals V2, we don't know, times 2.5 molarity. 50 times 15 is 750 equals V2 times 2.5. Divide each side by 2.5. And my V2 equals 300, and the unit is milliliters because V1 was in milliliters. How many milliliters of a 6 molar hydrochloric acid stock solution would it take to make 500 milliliters of a 1 molar hydrochloric acid solution? So this time I'm looking for V1. Milliliters of my M1, my V2, my M2. So V1 times 6 equals 500 times 1. 500 times 1 is 500. Divide each side by 6. And the volume is 83.3 milliliters. And again, it's milliliters because my V2 was milliliters. If that was liters, then V1 would be liters. And the last one, if you have 100 milliliters of 6M stock solution and dilute it to 1 liter, what's the new molarity? Now, this time V1 and V2 are not the same unit. They have to be the same unit before you plug it in. And it doesn't matter which one you change as long as you change one of them. And so it doesn't matter. I like smaller numbers. And so 100 milliliters is 0.1 liters. You could change the 1 liter to 1,000 milliliters, but then you have big numbers, and I don't like that. It really doesn't matter, though, which way you do it. So 0.1 liter times 6 molarity equals, we're looking for M2 times 1. 6 times 0.1 is 0.6 equals M2, so times 1. So there's my new molarity, 0.6. This test that you're taking tomorrow, well, Friday, depending when you watch this video, I really suggest you have your notes out and organized and have them by section, because we really have 4 different things going on here. We have on this test, we have polarity, we have IMFs, we have solutions, and then we have molarity calculations. Have all your work and your notes at least organized into these 4 sections, so it will be easy for you to go find the stuff in your notes. You do have a time limit, and I'm telling you, if you're not organized, it's going to be really easy to reach that 50-minute time limit trying to look for stuff and have stuff downloaded. So please, please, please be organized so you can do well and get your A this 6 weeks.